Okay, so we just finished U substitution. That's our really big topic for tool for integration. But I'm just going to give us some other tools. This one should be faster. I'm going to only go slow through 2 of these examples because theoretically you already know long division and you already know completing the square. So I'm going to go slow through 2 of them, but I'm kind of I'm going to put the expectation on y'all that you remember how to do this. And you don't need me to fully teach you. If you do end up needing me to teach you, let me know. I'll put something out there. I'll talk to you in class. But I really don't want to spend too much time on it here. But okay, starting with long division. And I'm starting with this question here. What is my indicator that I should use long division for this? Well, first off, I'm looking at this. I don't know how to integrate this. It's not just something I can do piece by piece. The second off thing is if I try to do a U sub, if I try to differentiate this, it's going to give me 4x plus 1, and this is an x minus 1, which, you know, that follows the general rule that I set up of, like, if I take out all the fluff, the derivative of this is just x, and this is just x. So let's try U sub and see what happens if there's anything we can do with U substitution. So if we say U equals 2x squared plus x plus 4, then du, let me zoom in so you can see better. Du equals 4x plus 1 dx. And how can I rearrange this to make it look like x minus 1? There's not really something I can do. Like because something I didn't say, but it's sort of been implied in my head, but I should say it now, is the only operations we can do here when solving is multiplying and dividing. Because what I could do is I could theoretically subtract 3x and subtract 2 from both sides. But then I'm going to end up with du plus or minus something, and that we don't want that. We don't know how to work with that. So I don't really know what to do with this du to get it to where I want it to be. So that's my clue that I can't use integration by substitution here. But I see we're dividing something, and I see my exponent on the top is bigger. Just wanted to check something real quick. Okay, so let's try just doing long division. So let's do x minus 1, or I'm sorry, 2x squared plus x plus 4 divided by x minus 1. And you probably have not done long division since Algebra 2, because it's in Algebra 2 that you learn this, and you also learn synthetic division. You could also use synthetic division here, probably. Actually, no, you can't use synthetic division. Okay, but the idea of this is still the same as what you do in elementary school. I'm going to say, what times x will get me to 2x squared? Well, that would be 2x. So 2x times x minus 1 times x will give me 2x squared. So I'm just multiplying my first term to match that. And then we're going to end up with 2x squared minus 2x here. And here's the part that you need to remember when we're dividing like this. Are we adding or subtracting these things? Well, we're subtracting this. So I'm going to put a minus and put it in parentheses. I'm not going to bother distributing, but 2 minus 2 is 0. A positive minus a negative is the same as adding. So x plus 2x is 3x. So we're left with 3x, and I'm going to bring down the plus 4. So underneath here we have 3x plus 4, and now we're still dividing by x minus 1, and we're just going to repeat this process. What times x will get me to 3? Well, that's positive 3, so I'm going to add 3 on the top. So x times 3 will give me 3x. Let's subtract it. We get 3x minus 3. And remember, we're subtracting. So what are we going to be left with? We're just going to be left with 1 divided by x minus 1. And here we're... Did I do something wrong? Oh, I did do something wrong. This is not supposed to be a 1. Hopefully you're yelling at me. 4 minus negative 3 is positive 7, not 1. Here we go. And here, what times x will get me to 7? Well, nothing times x will get me to 7. So this is where we're done. So we have a remainder, which I'm going to write the remainder as we're going to write it as plus 7 divided by x minus 1. And so this, our long division results in this. This is our remainder. And so we can rewrite our integral as this thing right here, as 2x plus 3 plus 7 divided by x minus 1. And we're going from 3 to 5, and we're integrating with respect to x. And now, this looks like something that we can take the integral of really easily, because the antiderivative of 2x is just x squared. The antiderivative of 3 is just 3x. The antiderivative of 7 over x minus 1 is 7 times the natural log of the absolute value of x minus 1. And we're integrating from 3 to 5. So now let's just substitute stuff in. We get 5 squared plus 3 times 5 plus 7 ln of 5 minus 1 minus 3 squared minus 3 times 3 minus 7 ln of 3 minus 1. And I sort of wrote it in a weird way, just because I was running out of space more than anything else. And it would be a really long line. But this are substituting 5 minus substituting 3 in. That's going to give us 5 squared is 25. Why did I write a 9 there? That should be a 2. I think I was thinking ahead. 3 squared is 9, so I put an exponent of 9. 25 minus 9 is 16. 15 minus 9 is 6. And then this is just going to be, we can't simplify that, so plus 7 ln of 4 minus 7 ln of 2. And that gives us this. And then I'm going to come over to the side. I'm just going to simplify it a little bit. 16 plus 6 is 22. And I have the advantage. This is a multiple choice question. I'm looking at the answer choices. So I'm just going to do something we could do to simplify it further. We can factor out a 7 from both sides. So we get plus 7 ln of 4 minus ln of 2. And this is the correct answer. We could do something else, but I don't think I'm going to say what that other thing is. Okay, so that's the first one. These second two are yeah, these second two. Still long division, go ahead and try and work it on your own when I come back. I'm just gonna have it worked out. I'm gonna talk through it really fast. Okay, coming back, talking through this, the long division process is very similar. The only one I want to point out is when we get to this 9, 2x times what equals 9x? Well, that's going to be 9 divided by 2. And then, yeah. And then here we get negative 27 over 2. This is our remainder. So negative 27 over 2 times 2x plus 3. That's also on the denominator, so I just put that there. And there's actually two ways you could approach this. If you distribute it out, you can get 4x plus 6, and then sort of u sub there. But you do need to use a u sub here because this doesn't look exactly like our derivative, our antiderivative, but it looks close to 1 over, so we need to make it look like that. So if you do a u sub, I didn't write it all out, but I did u equals 2x plus 3 and so on. I did the rest in my head, so I might have made a mistake. Hopefully I didn't. If I made a mistake, you can catch me in the comments, but I don't think I did, because if I take the derivative of this, it's going to give me 1 over 2x plus 3 times 2, so that becomes 1 over 2, yeah. I did actually make a mistake, but it's not a mistake there, it's a mistake here. This should be a negative, actually. So I'm glad I took the time to double check myself. Because I make these small mistakes, and if I posted this video, I would have been very embarrassed. The other thing I made sure not to forget is my plus c. Since it's an indefinite integral, we have our plus c. Okay, I'll let you, you can try and figure this one out on your own, then when we come back I'll have the answer, I'll talk through it really fast. Okay, so coming back, I started with my long division, nothing super fancy here, nothing I really want to talk about. We integrate the antiderivative of 3x is 3 over 2x squared. The antiderivative of negative 4 is negative 4x. The antiderivative of 9 over x plus 2 is just 9 ln times ln of the absolute value of x plus 2. And we're integrating from negative 1 to 1. So I substitute 1 in. I substitute, oh, I'm missing a parentheses. I knew something looked weird there, but I couldn't see what it was, but now I do see missing a parentheses. Negative 1 here. And this is just the quick simplification, and then 3 halves minus 3 halves, that goes to 0. Negative 4 minus 4, and negative 8. 9 ln of 3. Ln of 1 is 0, so this whole thing goes to 0 as well, and boom. Here's our antiderivative. Okay, now next one, for completing the square, this one I will go slow for the first one, and then I'm going to kind of pick it up for the other two like I did on this one. But okay, completing the square. I know in my head I can think of one student who has told me several times that they are not very good at completing the square. Well, this is your chance to pick it back up. Okay, so going through this slowly, completing the square. First off, what's my clue that I want to complete the square? Well, I don't know, I can't use sub this because if I use the derivative of this would give me 2x, and there's no 2x that I want to get rid of, or x that I want to get rid of. And I don't know anything that talks about a quadratic on the denominator. So what can we do? We can't use long division, because if we try and divide this, we're just going to end up with the same thing over again, because nothing times x squared gives us 4. So what can we do? Well, we could try completing the square. How do we complete the square? Okay, well, it requires this a and this b. A is 1, b is 4. What we are going to do is we are going to first figure out what do we need to add to make this correct, and we're going to add b over 2 squared and going through this sort of chain of thought, I didn't spend much time on it. B over 2 squared, b is 4, 4 over 2 squared, 4 over 2 is 2, 2 squared is 4. So we need to add 4 to this denominator here. So we're going to end up with 4 over x squared plus 4x plus 4. And of course, if we add 4, we have now made our denominator unbalanced. It's not the same as it was before. So I'm also going to subtract 4. And then of course I have this plus 8 at the very end still. Okay. And now let's make this look cleaner. This is going to be 4 over x squared plus 4x plus 4 plus 4 again. Dx. I should draw my little bar out a little bit longer. Okay. And now what we can do is we can factor this specific part right here. X squared plus 4x plus 4 lets us factor this thing here. This is a sum of squares. It's x plus 2 squared. I'm not going to spend time teaching how to factor. We should know that. X plus 2 squared plus 4 dx. And now this looks like something we've worked with before. This looks like 1 over something squared plus something. So what do we need to do? Well, we need to make this look like 1 over something plus something, 1 over 1 plus something squared. So that's what I'm trying to get to. So let's pull out the 4. I don't really have to do that, but I can. And let's rearrange it as 4 plus x plus 2 squared. And now, using a trick we used earlier, I'm going to factor out a 4 from both of these things. So I'm going to get 4, the integral of 1 over 4 times 1 plus x plus 2 squared over 4 dx. So I pull out a 4, and now I'm going to rewrite this to get it as a 1. And also I say 4 divided by 4, I'm just going to go ahead and get simplify that to 1. So we get 1 over 1 plus x plus 2 over 2 squared dx. And then this looks very similar to our arctan antiderivative. We're just going to have to do a u sub here. So I'm going to u equals, let me actually give myself a little more space. U equals x plus 2 over 2 du equals, that's just going to be 1/2 dx. So 2 du equals dx. So I'm going to be able to rewrite this as integral of 1 over 1 plus u squared times 2 du. And this is just our arctan. So this antiderivative equals arctan. I'm going to skip a step. I'm going to go ahead and substitute my u back in. It's going to be x plus 2 over 2. And then I'm just going to move this 2 to the front to be a coefficient. So we get 2 times arctan of x plus 2 over 2 plus c. Okay, so there's our first one. That's our antiderivative of this. Yep, just making sure I got the right answer. All right, I'll come down here, go ahead and try these two on your own. When I come back, I'll have this one, and I'm probably gonna actually move them down a little bit so I give myself some more space. Okay, and when I come back, I will have these two done, and we'll talk through it quickly. Okay, I'm really quickly going to come back and say something because I'm seeing a spot where I expect people to get stuck. When we add our 4 and minus 4 here, something I forgot to say that I should have said, we should make our a positive number. So when we have this thing here, well, actually, before I even do that, what I should have done is I should have factored out a negative here. So let me see if I can fit it in. Let me try and fix this. Okay, so I went through and I factored out a negative first, and then b over 2 squared, 4, add 4, subtract 4. Notice it's all inside the parentheses. And I'm factoring the first 3 terms. That gives me x plus 2 squared, and then I distributed this negative there. So then that would be a positive 4. So I end up with negative x plus 2 squared plus 4 plus 12. And from there, you can probably keep working on your own again real quick. Okay, and now talking us through this first one really quickly. I already talked through this part here. Then I just rearranged it. 4 plus 12 is 16, and I switched it because I know where I'm trying to go. I'm trying to make it look like our arcsine antiderivative. Factored out a 16. We get 1 minus x plus 2 squared over 16. And then using my square root rules, the square root of 16 is just 4 times the same thing, and then I rewrote this. So to get the 16 into the squared, I made it 4 because 4 squared is 16. And then here, 8 divided by 4 is 2. That's all I changed there. And I took this blue highlighted part. I u-subbed x plus 2 over 4, du dx, 4 du equals dx. And then 2 times 4 is 8. That's where my 4 went. And then I had 1 over the square root of 1 minus u squared. And this looks like our arcsine antiderivative. So we have 8 times arcsine. I went ahead and substituted our u in. It's x plus 2 over 4 plus c. And that's how I got this antiderivative right here. And our last one that we'll do, again, pause the video. I'm probably going to move this down. Actually, I am going to move this down to give myself more space because these problems are taking a lot of space. And when I come back, I'll have this one and we'll talk through it. And I'll come back if I notice anything particularly difficult here. I'm back already. I want to talk a little bit about the start of this one because something tricked me, which is why I accidentally tricked y'all. Let's talk about this one and let's put it in context of everything we've done. Would we be using long division or completing the square here? How can we know? Well, the big clue is that our x squared term, our numerator, which has the x squared, there's no b. So there's nothing I can add here that will successfully complete the square. So I can't do completing the square. What tells me that I'm using long division? Well, my denominator has a lower exponent than my numerator. So that's sort of a clue to use long division. The other thing to note here is that if I take the derivative of this, it gives me 24x, and I can't make that look like this. So we can't just use sub. So we should be using long division here. Okay, and I worked through this one here. When I did my long division, I end up with 6x minus 3 plus 3 over 2x plus 1. And I do the antiderivative of that. The antiderivative of 6x is 3x squared. The antiderivative of negative 3 is negative 3x. The antiderivative of 3 over 2x plus 1 is 3 over 2 times the natural log of 2x plus 1. And you should use a u sub here, by the way. I didn't show it this time, but you should have used a u sub to get the integral here. And that's all on, this is our final technique for integration that we're learning. My next video, which I keep saying, I keep trying to get to the last video here, but I keep finding more stuff to talk about. I believe my next video will be my last video for this unit, and we will finally be done with our integration unit and ready to move on to our next unit, which I feel like I said that like 5 videos ago at this point, but I think we're finally there for real this time. Surely. Thank you for watching.